Welcome to today's webinar, our regular webinar about the most frequently asked questions answered by the Dlubal support team. Questions of the last month that are often asked from our customers. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the website, the webinars, customer projects, newsletters, and so on. I will be the moderator today, and I will also be the presenter of the first part of the webinar. Then I take over the screen and the words to Jürgen. And Jürgen, you can introduce yourself.
Yes, thank you, Andreas. I am Jürgen Teilmann. I've been working for Dlubal Software now for a bit more than 2 years. I mainly work in the customer support, and I'm also responsible for creating new FAQs on our website. And that is the reason why I'm the guy who will further on present these webinars of the frequently asked questions. And like Andreas said, he will present the first half of this webinar. In this time, I will answer your questions. Any questions you have, you can ask here. And in the second half, I will present the questions and Andreas will answer your questions. Yes.
Exactly, yeah. Thank you for your introduction. Maybe additional information from my side. I've been working for the company for 13 years now. Okay, then we can switch off our webcams that the attendees can see the full screen. Okay, then again, you can see the control panel on the right side of your screen. And you can show the panel with that arrow and enter the question here. You can also watch the entire webinar and then email your questions to info@dlubal.com. Okay, then I switch to the program and to the first model and the first question. The first question is, I used mass type loads in my model. However, they are not considered in the self-weight. What do I wrong? Okay, I prepared that model with that rigid column and the mass load. The rigid beam is haven't got any load, as most of you know, and the mass is a category of a load type. Usually you use force, but for example, for a dynamic analysis, where are often used the mass load type. And if I click to the results, you can see there is no support reaction. In the navigator results, you can see it's checked on. And you can also see there are no loads. And in the table, if I go to static analysis, there are no support forces. How can you solve that? You need to go left at the bottom. I switch to the navigator data. And I need to open the static analysis settings. Either you click with the right mouse and click edit, or you can also find it under the loads and combinations, also with right click. And then you see in the load cases the static analysis settings. That's the same topic. And if you click to the edit button, then you come or turn to this sub dialog, and in the basic settings, where is this check? And if you activate the mass, then the masses will be converted into loads. With that factor in Z direction 1 times. You can also press this button to switch between the vector and the acceleration. Yeah, now you can see the acceleration of 10 meters per square second. Yeah, the usual acceleration due to gravity is 9.81, and that value is rounded up by the program. Okay, now it's activated. I can click OK and calculate the self-weight load case. And now we should see a support reaction. Okay, now you can see it. 0.1 tons is 1 kilonewton. Okay, that was the first hint and the first question. I turn to the next model and the next question. And the next question is, how can I display the load distribution in the results of the static analysis? Yeah, you can see that in the navigator results, left at the bottom. And where is this check? Distribution of loads. If I check this, you can see the load distribution. And the load distribution represents the load that is actually applied on the structural system in the FE mesh points, and if applicable on the FE areas. Yeah, and the FE mesh size plays an important role. You can see there are two, the models are equal and also the loads, but there are two different FE mesh sizes. I can show that when I go to above to mesh settings. That's the standard mesh setting, 50 centimeters. That's this surface, and if I click on this surface, you can see I've defined a mesh refinement. And if I switch to that dialog, you can see the mesh refinement, 0.2 meters, 20 centimeters. So, and you can see in the different models and the different load distribution that in this model, the load distribution area is larger. And sometimes it can be, I've got an influence on the results. Let me check on the support reactions. So I turn it a little bit. And you can see there are different values, 0.74, 0.63, or if I rotate the model, you can see the highest value, 0.7. This is 1.0. The loads are not very high. That is why the difference is not too large, but that can really influence your results. Imagine there's a horizontal beam over an opening or something like that, and that's the applying of the load should be correct. Maybe you ask what is the best FE mesh size? We can't say that. We can only say the FE mesh should be as large as possible, but as fine as necessary. There's isn't any value that we can say or that we can suggest. When you have got a surface load that is load the complete surface, then you will see no difference or only a small difference in the results. But for such examples, and when you have got maybe horizontal beam in the near that can be influenced the results. Yeah, you must test it. But with that setting, you can display the distribution of loads and also the support reactions. Okay, then I turn to the next example or next model and the next question. The question is, I have used a clipping plane in my model. The hidden areas are still shown as transparent in the display. How can I completely hide them? Let me switch on in the guide objects, the clipping plane. So you can see the clipping planes here. The default setting is, I increase it a little bit, that you have got the 3 areas as default. They are created by default and you need to only to activate them. Let me take on a clipping plane. You can move the clipping plane. Sorry. And you can see there is a transparent area. And the question was, how can we completely hide this? We turn to the navigator display here at the bottom, then in the general settings, and there's this check, show clipped areas. So when I switch it off, you can take a look in the model, and that's quite better if you want. That's the difference. So, and if you want to modify this area here of the clipping plane, then you can click with a right click on this edge here, for example, and turn to the display properties. So I move it a little bit on this side. And you can change that value, for example, 0.1, apply, and you can see the difference, 0.9, apply. Okay. So and there's another feature, show hidden objects in background. And it's not the same feature as this one, show clipped areas. When you, for example, select one column, then hide selected objects, you can see they are gray. And if you want to hide them completely, then just uncheck this. Okay. So that's all from my side, the first 3 questions. And now I hand over the screen to Jürgen, and he will continue with the next 3 questions.
Yes, thank you, Andreas. I will show my screen. It's screen number 1. Yes, it should be visible now. And so far there are no questions open. This is why I will continue with the 4th model I have prepared now, which is about the fatigue design in concrete design. And the question is pretty simple. What do I do? How can I perform the fatigue design check in RFIM 6? First of all, I will show you what I have here. This is a simple, I just collapse the tables a bit so you can see the model I have here. This is a member model, but you can also perform the fatigue design on the surface models. And I have, well, this is a kind of a traffic route. This is a ceiling in, let's say, some kind of factory where you have traffic for maybe forklifts who drive around, and you can see in the load cases that this is kind of a moving load from a forklift which is driving along this member right now. And this leads me to the next part of this questions. Where do I need the fatigue design? It's mainly developed for bridge design, but as I said, other traffic routes, and maybe you have some rainwater basins with traffic around. So you can generally say the fatigue design is for structures where you have a lot of load alternations with load cycles of 1 million or more. Then maybe you will need to perform this fatigue design check. Okay, so what do you need to do this? I will expand my table a bit more to show you in the concrete design add-on how you can switch on this fatigue design. First of all, there's a button with an Earth globe and a small cogwheel. This is for the global settings of our add-on. And there in the ultimate design configurations, you can activate the fatigue design, which is first of all the first thing you need to do. Then I say OK. And now I go to the ultimate configurations. And there you have a new tab for fatigue. And in RFrame, you are now able to perform 2 ways for the fatigue design, the level 1 and level 2 from Eurocode. And for these different kinds of levels, you have the level 1 is a simplified method. Level 2, as you can read, is for a damage of equivalent stress range. And you can do some modifications there too in the level 2 design. I click that. You can use a correction factor lambda s, which is from bridge building. If you are from bridge building in your daily work, you know what this means and can edit it accordingly. Otherwise, you can use an interval of a defined number of cycles for your load alternations, which is by standard set to 1 million, but you can also edit another value just as you need for your project. So I switch this back to the level 1 design and switch off this. So that's the second thing you need to consider. The third thing is, because we are dealing with load alternations there, you need a design situation where you have these alternations in it, and that's why it's best to have at least one result combination in your loads. So therefore, I now go to the top where I have my load cases, and I open the dialog for my load cases and combinations. Now I have 3 design situations in this model. First one is the normal ULS design situation. Then I have the serviceability check frequent. This is for my level 1 fatigue design. And for the level 2 fatigue design, we would need another design situation where you have, I just open the one that's open right now, where you have other factors that need to be considered. Our development is right now working on bringing this design situation type into the program. Unfortunately, it's not 100% ready now, but that's not a problem. You can always build your result combinations manually, but in our example today, it's sufficient that I use the SLS characteristic for our level 2. But this is now just for this example. Later on, you will find the matching design situation type for that level 2 fatigue design check here. And when I go to the overview of my design situations, you can see right now that I have result combination 3 for my level 2 fatigue design and the result combination 2 for my level 1 fatigue design. Okay, let's go back to OK. I go into the table for design situation, And now you could easily say, okay, I calculate all my design situations, but I just want to show you, okay, right now we're doing the level 1 and then we're doing the level 2. It wouldn't make a difference to have both activated because the program will only perform the fatigue design according to the level we chose in our ultimate configurations. Good. Now I deactivate this DS3 once again, and I'll show you in the level 1. I will add a comment so there's no confusion. For the level 1 design check, we have the basic design situation type SLS frequent, and now we need to change this to the ULS fatigue non-cyclic. So that's the one we need for level 1. I start the calculation and you can now see that the program is running all the load cases simultaneously, all at once, yeah. And now it's performing the concrete design. So I scroll out a bit and you can see that there's the overview. We have not fulfilled our design checks for the fatigue. So here's the design check for shear and here's for the longitudinal reinforcement. I will open my design details by a double click. And then you can see, okay, here's the design check in detail, and then you can do something against it, maybe increase the amount of reinforcement or use another material. That is up to you. Another thing I want to show you, now we have a factor of 1.06. Well, it's almost fulfilled, but not entirely. And now I say, okay, I have done the result combination for the level 2 design check. And this is why I will show this to you. Go back to my input data. I deactivate this design situation and activate the other one for the level 2. And like I said before, if I calculate now, there will be no fatigue design check performed because I still have to activate the level 2 in the ultimate configurations. So it's what I do now. Say OK and calculate again. You see all the load cases are still calculated. The program starts with the concrete design check. Now you see, okay, we have invested a little bit more of calculating power, a little more of computational power, and now we're a little bit better for our fatigue resistance. Still not fulfilled, but as I said, that's up to you. That's the work you will have to do further on. Okay, as a summary, this has been a lot of information right now. As a summary, I can tell you we have 4 points we need to consider. First is in our global settings for the add-on, we have to activate the fatigue design. Second thing is, in the ultimate configurations, we have to choose the level of design check we want to perform. Third thing is, we need the correct design situation and change to the correct design situation for fatigue. And the fourth point is that in those design situations, we need at least one result combination. Okay, if you need further information on this fatigue design, I will jump to our website because there's a very good technical article. You go to www.dlubal.com. You hover over support and learning with your mouse, and then you go down to support and knowledge base. And now, because it's our newest one, you can see the fatigue design according to Eurocode 2 in RFM 6. as we go further on, there will be newer articles coming out every week. So you can go to full text and you say fatigue, search for it, and then you will find this technical article. So if it was a bit too much for right now to get into your head, and you can always go back here to our knowledge base and read all the details about this fatigue design checks. Good. That's all for our fourth question today. And now I have the fifth one, which is a very general question about punching design, which says I have a reinforced concrete plate or slab which has several nodes for the punching design. Some of them are wall ends. However, the program doesn't carry out the punching design check for all of those nodes. What is the reason for this? So I have a small model here. You can see it's a bit of a ceiling. We have load cases for our imposed loads on that ceiling and from the levels above. And we have different load combinations within. I just restricted myself to the ULS design situation here. So, and now I want to perform the concrete design on this and just start the calculation. Okay, you can now see I have visualized my punching design checks here and here and here, but suddenly on the right side there's no punching design fulfilled. I turn the model around. You can see this is very similar to the left one. Here's the right one, and you can see that there's absolutely the wall end is not considered by the program, and therefore there is no punching design. I also have no error message whatsoever, and well, that's what we usually get in the support. So there are some methods now to approach this. First of all, I check the results and I see, okay, there is no error message. Normally, if you get an error message, you get a text saying, yeah, this and that, something is missing, something needs to be activated, wrong material, whatever. This is not the case in this model now. So now I go back to my input data. I check the design situation is active. I check the objects to design. Usually you can just uncheck design all and select the nodes for design by hand. So maybe the nodes of interest are just not selected. So I now select these two where I think something's wrong. And now I just want to design these two nodes. So I also get no message for removed or not valid. So these nodes should be valid for my punching design. I also check my line supports. So you can see what I have defined here. I have also visualized them to represent those fictitious walls for the stiffness of these line supports. Just open them to see, okay, what's going on here. This stiffness via fictitious wall. All is edited here. And by the way, because another question asked many times is why am I not able to choose this option stiffness via fictitious wall? That's because of the coordinate system you choose for your line support. By default, this is set to global, and then you cannot choose this fictitious wall. So if you want to choose this option, you need the line support orientated to the local line axis system. Yeah, but that's another question I have answered here. Okay, brings me back to our notes for the punching design. Let's go to the notes themselves, because it can easily be that you haven't activated them within the notes themselves. So this check must be set, so the node can have ultimate configuration assigned to it. Otherwise, there would be no punching design performed. But that's also not the case in this model. And yeah, that's for the settings for the add-on, but still no punching design for these two nodes. I go to my navigator views to see, okay, maybe there's some self-defined view I've generated, but no, all is active. You can also go to the top bar. There's this microscope symbol and say, okay, cancel visibility mode, but these are all canceled, all should be visible. Now there's a third option. When I go to my navigator display, right now you see, oh, members are not active. Okay, this could be the case. Well, since I mentioned it now, you know that this is the case in this model. And another, if this is not the case and it's not so easy to spot, you can always do a right click on that navigator display and set all your display settings to Dlubal standard. And then the members will get activated as well. And I zoom in and you will see, oh, there's a member going through at the corner of this slab, and this is now hindering me from performing the punching design. I just delete this member out, so maybe this has been forgotten to delete, or maybe it's there and then you actually don't have a node for punching. I just delete this middle part, start the calculation. And now you will see for my two nodes, I have selected the punching design now is fulfilled. Now they are recognized as wall ends. For the foreseeable future, there will be a design, a check coming that will give you a warning that the topology of these chosen nodes is not valid for a punching design. But at the moment, you will have to use the few hints I've given you to search for possible causes that the punching design is not performed. Good, let's go to our last question of the day. I go to this model. And this is asked really, really often because many of you, especially when building multi-story buildings, you're working with DXF files as background layers. And there's always the question, how can I move them? How can I align my stories correctly? And here I have a small, it's a small multi-story building. So I have 4 background layers inserted here. And what I intended was to have this, when you follow my mouse pointer, to have this wall be on top of each other in all stories of my building. But when I look on it from the top, you can easily see, oh, I have got something wrong with implementing my background layers in the file. But that's not a problem. That is now easy to correct. I go to my navigator data, to the guide objects, and there we have our background layers. Usually you perform a right click and say new, but I go to edit because I already have them in here. We go to our first layer. You see it's at the origin of our global coordinate system. We have the DXF file, and we can choose an insert point. This is by default set to center, which is the center of the whole DXF file itself. You can choose some other pre-selected insert points, and you can see that lower background layer switching around. But these are just predefined points defined by the outlines of your DXF file. And maybe like in my case, I want to present here, you have a certain reference point you want to use. Maybe it's aligned to your maybe it's aligned to a frame you have, or maybe to your building grid. So that's why I will show you how to select your insert point in the preview. And that's done at this section here, at this origin point section. There are two pretty similar pointers right here for the picking. The left one I'll show you is for where in my RFIM model will be the origin point. And the right one is for where in my DXF file will be the origin point. So you see, I don't switch to RFIM. I'm still in this dialog for the background layers. And I can now pick my reference point I've chosen for this building and hit apply. And this is now a bit of a finger exercise. Go to my second one, select in preview. You can see I have already assigned my origin point for the model. So it's 3 meters above. So I only have to choose my insert point of within my background layer. Go to the reference point, hit apply. Next one, select in preview. This now goes really fast once you've done it 2 or 3 times. Hit apply. And now for my top story. Hit OK. You can see the background layers are moved now. And if I look on the model from the top, using my view cube to do this, you see my background layers are now aligned in the correct way and all on top of each other, especially in my reference point. Some of our customers already know about this topic with the reference point, so maybe they use lines of their building grid as a reference point, or they simply add a small pointer where they say this is my reference point in every story, and use this to really get those background layers aligned. Yes, that's all from my side. Thank you so much for now, and back to Andreas, I would say.
Okay, thank you, Jürgen, for your questions or your answers. Thank you. Yeah, before I close the webinar and I show you the website where you can find the recording in the next days, just a small hint. If you want to get your free product demonstration or something like that, just contact our sales team with that link here in the PowerPoint, or you can scan the QR code. You can download the PowerPoint from our website. You can also, if you are interested in some of our products, and you want to get the non-binding offer, you can also contact the sales team. Okay, then, as promised, to our website, dlubal.com. Under News and Events, you can find the webinars. This is already the webinar of the next week. Then this one for the week after next week. Sounds very interesting. The integration of artificial intelligence with the API. Then aluminium design, stress analysis of stairs. Those are already the most frequently asked questions webinars of the next year. And this is the webinar of today. So I click on it. When the recording will be online, you get an email with a direct link to that page. You will also get the attendee certificate, and then you can find the recording in the middle or on this side. It doesn't matter. You can already download the presentation slides, and those are the models of today's webinar. Okay, that should be also all from my side. Maybe last hint or last wish, when you leave the webinar, there's a small survey. It takes you only 1 minute. You can score the webinar. Just note that the worst score is 1 and the best score is 5, as you give stars. You can also enter wishes for future webinars, but you can also leave the field empty. Okay, then thank you for your attention. Thanks to Jürgen for the presentation. I hope we meet each other in a future webinar. Bye-bye.
Goodbye.